Very good morning, friends. A hearty welcome to my YouTube channel. And in today's video, we are going to work out a problem on a journal bearing, wherein we have been asked to find out the viscosity of the oil required to sustain a load at a given temperature. The question for today's video reads as a 75 millimeter long journal supports a load of 7335 on a 50 dia. He has given the load, he has given the diameter and all the length of the journal. The speed is being given. The diameter clearance is some value. Diameter clearance is small c in the formula we are going to use later on. Is that what should be the viscosity of the oil when the bearing temperature is given and also room temperature is given. So in this problem, friends, at the end is telling assume that the heat generated in the bearing is all dissipated. So only based on this condition we will be able to find out, that is, the total heat generated in the system or the heat generated in the system is totally removed. That is, in other words, the Hg is equal to Hd. So as per the problem, as per the data, we have Hg is equal to Hd. Means this is the heat generated and this is the heat dissipated. So when you equate these two and by substituting all these values of the load, the dimensions of the journal, etc., we should be able to find out what is the value of the viscosity of the lubricant. Friends, we can write this Hg and Hd in terms of the known parameters as Hg can be taken as mu times W into V, mu WV, and Hd is taken as CAT, that is TB minus TA. So these are the equalities. So we'll have to find out these terms separately. Load is given, bearing temperature is given, ambient room temperature is also given as 21 degree. So we have to equate these two. So we will calculate Hg separately, Hd separately, and then equate these two to obtain the value of the viscosity of the oil required. So friends, you write down here this Hg, that is the heat generated in the bearing is given by mu times W into V. Mu is the coefficient of friction. Generally, we make use of Mackey's equation if nothing is specified. So, mu Mackey is the value of coefficient of friction as per Professor Mackey's is given by Ka eta n dash by P 1 by psi 10 to the power of minus 10 plus delta mu. Friends, this equation is available in the machine design handbook, MDHL write down. This is available on this chapter, lubrication and bearing. So friends, this term Ka is equal to a constant that is given as 1.95 into 10 to the power of 11. Just below this equation, this constant is given. Then friends, eta is the viscosity of the oil, viscosity in Pascal second. That's nothing but 10 to the power of minus 3 eta 1, where this eta 1 is in centipoise. So we have to find out this value of eta 1, that is under question mark. Now friends, we have this n dash. N dash stands for the speed of the journal, that is n by 60, rpm by 60. The rpm is given to be 750, the speed of rotation, by 60. So 6 ones are 6, 1, 12.5 rps is the value of n dash. Friend, this pressure P is equal to load over area is L into D. The load is given to be 7335 Newton, and the length and diameter, the length is 75 mm and the diameter of the journal is 50 mm dia. So friends, if you simplify this, you get the value of this pressure as 19.56 into 10 to the power of 5 Newton per meter square. This is by 1000, you have to multiply 1000 by 1000, that is into the value. L and D are given millimeters, so that has to be converted, and this works out to 19.5 into 10 to the power of 5. So 10 to the power of 6 I will take here, because this is millimeter by 1000, that becomes a value 19.56 into 10 power of 5. So we have this value, this is question mark, this is known, speed is known, price is known. Psi is the ratio of C by D. C is the diametral clearance, and you should be very careful. Sometimes C is, instead of giving the diametral clearance, radial clearance will be given. So in the formula it is diametral clearance, which is 0.006825, 0.006825 divided by the diameter of the journal is 50. Friends, if you find out this 1 by psi, the reciprocal of this, that works out to 732.6. So we know this value, the constant, and this delta mu, friends, is called the correction factor for end leakage, and its value is 0.002 for L by D ratio from 0.75 to 2. So this is valid for that reason, that is the value is 0.002. Friends, if you make the substitution of all these in the equation, you are going to get this mu the mu of Mickey's as this is the value you have got, and friends, this W is the load 7335 Newton. Velocity is pi dm by 60, pi by 60, and W is so much. The velocity will write down separately. Pi dm by 60 meter per second. Pi by 60. Diameter is 50 by 1000. To convert millimeter to meter, into speed is 750 rpm. Friends, if you substitute these values, you finally get the value of this velocity as 1.9635. 1.9635. It is in meter per second. Meter per second is the value of velocity. Friends, we know this value is given. Velocity we have calculated. So if you simplify this, friends, you will get this value finally, and you can simplify this. Later on we will equate that. So the value of Hg is going to work out in terms of the viscosity of the oil, that is eta 1. Friends, now we'll find out what is HD. HD is heat dissipated. H is the heat dissipated. Friends, this is given by the formula C into A into TB minus TA, where, friends, this C is a constant and its value is given to be 9.6 watts millimeter square or degree Kelvin meter square. This is the value of C. This is given below this equation, and this equation is also available in the machine design handbook. Capital A, friends, stands for the area of the bearing, that is 25 dl it is taken. So 25 times diameter is 50 by 1000, and this L is 75 It's given in the question 75 by 1000. So you will get the area, so many meters square. So we know this area. C is known, and TB and TA. What are these TB? TB stands for the temperature of the bearing surface. Temperature of bearing surface. Bearing surface. And friends, this value is given to be 77 degree. The temperature of bearing is 77 degrees Celsius, and TA is the ambient temperature or the room temperature, and that's also given as 21 degrees Celsius. 21 degrees Celsius. So friends, you will get the total value of HT in terms of watts. And if you equate to Hg, in Hg, the only unknown parameter is the viscosity of the oil, and hence you will be able to get the answer of the viscosity as 16.425. 16.425 centipoise Cp. This is the answer for this question. Friends, remember, you can find out the value of the viscosity only when the condition that the heat generated in the bearing is totally removed or dissipated from the system. Friends, I hope the presentation was interesting. Please go through the complete video, and if you like the video, please share with all your friends without fail. And if you have not subscribed to my channel till now, do subscribe it today without fail. Have a wonderful day. Thank you very much.